Hi guys, so today we're going to look at nth roots and rational exponents. Now a lot of this actually will be somewhat of a review for some things you guys have learned back in Algebra 1, but some of this might be a little bit new. So before we get started, I just want to review a couple things that you've probably already seen, but are going to be very important for the units we have coming up. First of all, just our basic exponents. So these powers listed are ones you just really need to be familiar with. They're going to come up a lot, not just in this unit, but they come up a lot in our next unit once we start doing logs as well. So these are some of the most common ones you're going to see. So for example, 2 squared, we need to know 2 to the third. So basically we need to know our 2 exponents up to at least 2 to the 6th, okay? Our 3's, it's really good to be familiar with at least these ones. So 3 to the 4th, remember 3 to the 4th, that one is the same as 3 squared times 3 squared, which gives us 9 times 9. Okay, so let's keep going. So we've got 16, 64, and then 4 to the 4th would be 256. Okay, so then let's go to our 5's. So we have 5 squared is 25. 5 to the third is 125. And then 5 to the 4th is 625. Okay, and then this next one, this isn't actually 6 minus 15 squared. Basically, you need to know 6 squared, 7 squared, 8 squared. So everything's squared up until about 15 at least. These are the ones, again, these are just the ones that are going to come up the most often. And the faster you can recognize these, it can just save you some time. So most of you probably know through 12 just because of your normal times tables. 13 squared is 169. Okay, then we've got 14 squared, which should be, I actually don't remember that one, I'm being a hypocrite, 196, okay. And then we've got 15 squared, which is 225. All right, then I wrote 10 to the anything just because if it's 10 to the first, 10 to the second, 10 to the third, okay, basically it's the same number of zeros, okay. And if it's negative, then it goes the opposite way, but we'll talk about that in a second. All right, so just to review, simplifying square roots, first of all. There's 2 different methods you may have learned to simplify a square root. One method was to think about what perfect squares can you divide from 32. So for example, our perfect squares are like 1, 4, 9, 25. If any of those values can be divided out, then we can divide that out. So like 32 is divisible by 16. So that's the same thing as the square root of 16 times the square root of 2. So the square root of 32 can reduce to 4 root 2. Okay, 4 to the negative second is the same thing as 1 over 4 to the second. Oh, sorry, before we do this, I want to show you the other method. Apologize. The other method you may have learned is with the factor tree. Okay, so what you do is you take your number and you come up with all the numbers, come up with 2 numbers that multiply to 32. So that would be like 8 and 4. And what I want to do is I want to break this down until I get to all of the prime factors. So I keep breaking this down until the numbers at the bottom are all prime numbers. So now I'm just going to look at the bottom numbers. Okay, any number at the bottom, and they don't have to be next to each other, but if there is a pair, so if there are 2 of the same number, anytime there's a pair, that number gets multiplied on the outside. Whatever's left over stays on the inside. So this would be 2 times 2 root 2, which gives us the same thing as 4 root 2. So either of those methods will work. It depends just what you've learned in the past and what's easiest for you. All right, so going back to B, a negative exponent basically moves it to the bottom. So 4 to the negative second would be 1 over 4 squared, which is 1 over 16. 4 to the 1/2 is the same thing as the square root of 4, which is not just 2, it's actually plus or minus 2. But for today, we're not going to worry as much about the plus or minus. We'll use plus or minus a lot, though, when we get to solving. And then looking at D and E. Okay, D and E are actually different questions with different answers. And this is a mistake that probably some of you have made on your calculator before. So a lot of times you're trying to evaluate this, and you end up typing in this, and you get different answers. And I just erased instead of wrote. So negative 7 squared is the same thing as a negative 7 times 7, because order of operations, you do the exponent first. negative 7 times 7 is a negative 49. Whereas negative 7 squared is negative 7 times negative 7, which is a positive 49. Okay, so again, where that negative is in the parentheses does make a difference. So what we're going to look at a lot today are rational exponents. Okay, so rational, remember, we just did rational functions and those were fractions. Okay, so these are going to be exponents that are fractions. Whenever you have it, you're going to have a number at the top and a number at the bottom. The bottom number of that fraction is the root that we're taking. Okay, and I like to say is to think about the trees. The roots are at the bottom of a tree, right? So the root is the bottom number. So x to the 3/4 would be the 4th root of x cubed. Now what's nice about these is actually it doesn't matter which order you go in. You also could do this. This is the 9th root of y, and then we could raise it to the 7th power after. You'll still get the same value depending on, it doesn't matter which one you do first. For the work that we're going to do though, typically it's going to be easier to take the root first because that's going to bring you to a smaller number as opposed to getting some really large number and trying to root it. All right, then let's look at C. So C, remember, parentheses matter, okay? X does not have an exponent. It is not being raised to the negative 1/4 power. The only one being raised to the negative 1/4 power is y. So this is y over the 4th root, x over the 4th root of y. And then on D, both of them are to the 1/2 power, so it is the square root of both of these. All right, and then we're going to go the backwards way. We're going to take a radical and write it with fraction exponents. So x and y are both being raised to the 4/3 power. Again, 3 is the root, it goes at the bottom. Okay, so the root goes at the bottom. So on this one, x and y are not both being raised to the 4th. X is being raised to the 1/8, and y is being raised to the 4/8. And if we want, we can actually reduce that and say that's y to the 1/2. All right, on C, this is the cube root of negative 5. Now, if you remember, we can't do the square root of negative 5 because there are not any two real numbers that can multiply to give us that negative. But if it's an odd root of a negative, that actually does work because there are numbers, if you multiply a negative times a negative times a negative, that is going to give you a negative. Okay, so the cube root of negative 5 does actually exist. Now, it's not a pretty number, but it does exist. So we could rewrite this as negative 5 to the 6/3, which I would rewrite as negative 5 squared, which would be the same thing as 25. Again, it would be positive 25 because negative 5 is what is under that root. So that whole thing is being raised to that 6/3 power. All right, and then looking at D, okay, so I'm going to have x to the 10/5. Y is to the negative 1/5. So this becomes x squared. This is y to the negative 1/5. All right, so again, kind of what we talked about briefly here. You can take an odd root of a negative. Okay, you cannot take an even root. So we can't do the square root of negative 7. We also cannot do the 4th root of a negative 16. Okay, it will not happen. But you could do the cube root of a negative 8 because negative 2 times negative 2 times negative 2 will give you negative 8. All right, and then also, we mentioned this briefly, if it's an even root, there will be a plus or minus. Okay, so that's a big difference between your odd and even roots. All right, so now we're going to get some practice into these. Now, I want you guys to try these without a calculator, okay, because these are some that are, the more they're going to come up faster, and you need to be really comfortable with these types of questions, okay? Especially, even if you don't do as much from this unit, we're going to do a lot in the next unit as well once we get into logs. Okay, so 27 to the 4/3, what that means is the cube root of 27, and then we're going to raise that to the 4th power. So the cube root of 27 is 3, and then 3 to the 4th is 81. Okay, 16 to the 5/4, I would take the 4th root of 16, which is 2. I would raise that to the 5th power, which is 32. Right, 4 to the 1/2, we already said this, that is the square root of 4, which is plus or minus 2, technically. 4 to the negative 2nd is 1/4. 4 squared, so 1 over 16. And these two questions get mixed up a lot. So you got to be really comfortable knowing the difference between the fraction exponents and the negative exponents. All right, the last one, it combines the two together. So this is going to be 1 over the square root of 4. So this is 1/2. And again, because we took a square root, technically this would be plus or minus. Now, if you're doing an odd root, it's no plus or minus. It's just the one answer, okay? And again, for today, if you don't put the plus or minus, that's okay. It'll really be important once we get to solving, though. All right, so talking about our tens, so this is the 6th root of 1,000, and the negative is out in front. It is not in the parentheses. So this means that I'm going to find the 6th root of 1,000,000, and then that answer is going to be negative. So this is a negative 10. Whereas on G, I'm doing the 6th root of a negative 1,000,000. That has no solution because I can't take the 6th root. But if this was the 5th root of a negative 100,000, that does have an answer because you can do an odd root. So this is negative 10. Okay, so there was a difference between all of those questions for different reasons. All right, so this next part, this is probably the hardest part. So we're going to simplify radicals like we did on that first review question and like you did in your warm-up in class, but we're not going to be doing just square roots. We're going to be looking at cube roots and, 4th roots. So to start, let's deal with 32. Okay, so depending on which method you use, I'm going to show this with the factor tree because I think it's a little bit easier. So I'm going to break down 32 into all of its prime factors. So I just keep going until I'm down to all prime numbers at the bottom. Okay, so I'm left with all 2's at the bottom. So because this is a 4th root, I'm looking for any sets of 4. So there are 1, 2, 3, 4 2's at the bottom. So 2 is going to be on the outside. Okay, then left on the inside, I'm still going to have a 2. Okay, then let's look at our variables. Okay, a very similar way. This is x to the 6th. So x to the 6th means there are 6 x's. So if I'm taking the 4th root, I'm looking for a set of 4. Okay, well there are 4 x's. So that if I took the 4th root, there would be 1 on the outside, and there are 2 left over. Okay, then let's look at y to the 5th. Okay, if there are 5 y's, I have 1 set of 4 with 1 left over. So 1 comes out, 1 left over. All right, and then last, we have z to the 12th. So again, if I took out all the sets of 4, there would be 3 of them. So that would be z to the 3rd, and there'd be none left over. So if you feel comfortable with this, pause the video and try the next one. But I'm about to go ahead and work this one out. Okay, so let's look at 40 with a factor tree. So breaking it down into all of its prime factors. So I'm looking at all the bottom numbers. Okay, there's all my bottom numbers. I'm looking for sets of 3 because it's a cube root. So there is 1 set of 3. So 2 comes out. 5 will be left on the inside. Okay, x to the 7th. Okay, that means there's 7 x's. So I'm looking for sets of 3. I could take out 2 sets of 3 and I'd have 1 left over. Okay, with y's, I could take out 4 sets of 3 with none left over. And then with z's, I could take out 1 and I would have 2 left over. Now, if you use the dividing out the factor in your head, you also could do that for this method. So just think of what perfect cubes you know. Like 1 cubed is 1, 2 cubed is 8, 3 cubed is 27. Well, we know 40 is divisible by 8. So if I took out that cube root, 2 would come out. 40 divided by 8 would leave me with 5. Okay, so that's how you could work it out without doing the factor tree. So last one we're going to look at are just some basic equations. We're going to do some harder ones later on, but for now we're just starting with kind of a basic equation here. So what I'm going to do is I'm going to get x by itself, so I'm going to move that 24 to the other side. All right, I'm going to take the fifth root of negative 64. So there is no perfect number that's going to work this out, but what I can do is I can simplify this the same way that I've been doing all these other problems so far. Okay, so I'm going to take the fifth root. And again, 64, it doesn't have anything that goes into it. There's a number I can multiply 5 times to get there. But if you know your powers, I know 2 to the 5th is 32. So I could take out that 32 and I would be left with 2. So that's how I could simplify that. What I also could do is I could do my factor tree, okay? And look at your prime factors. So 1, 2, 3, 4, 5. Okay, there's one set of 5, it's a 2. There's 1, 2 left over. All right, so now let's go to this last one. All right, so at this case, again, just order of operations here, we would need to take the fourth root before we do anything. So I would take the fourth root here. So I'm left with x minus 2. And then I've got the fourth root of 30,000. So again, I think about what prime factor or what number to the fourth I could factor out. 10,000 would be 10 to the fourth because there's 4 zeros. So 10 could come out and I'd be left with 3. And then all I would do is I would add 2. And then this should be plus or minus, remember, because we took an even root. Okay, so because we took an even root, it is plus or minus. Okay, so even roots are plus or minus, and then even roots, you can't take an even of a negative. You can't take an odd root of a negative. And again, if you did factor tree here instead, okay, we could do, let's do 30 and here, so 15 and 2, 5 and 3, 10 and 10, so 10 and 100, 10 and 10. All right, so again, we're looking for 10, oh, sorry, my 10s would keep going into 5s and 2s, but trying to make this a little shorter for you guys. So I've got, this will be a 5 and a 2 and a 5 and a 2 and a 5 and a 2 and a 5 and a 2. I ran out of space. Let me make this a little easier to see for you guys. There we go. So 5 and 2, 5 and 2, 10 and 10, 5 and 2, 5 and 2. Again, looking for sets of 4. So 1, 2, 3, 4. So a 5 goes on the outside. 1, 2, 3, 4. A 2 goes on the outside. 2 is left over. So 5 times 2. Oops, that should be a 3, not a 2. I wrote, sorry, bad handwriting there. That was a 3. So that 2 was in there. Sorry about that. But again, you do get the same value with your factor tree. All right, so again, kind of the information in the box in your notes is probably the most important stuff for today. Just remember when you have those fraction exponents, the bottom number is the root and the top number is your power.